All right, so these are the solutions that are posted. This page is your R1 to 1, 1. I mean, it's R1 and R2, because remember, this is not in your book, okay? So this was the lengths of the triangles, their side lengths of the triangles. This is your distance formula, classifying the triangle as either right, equilateral, or isosceles. Then it was find the circle, or the equation of a circle with the endpoints that are given there. You got to find the midpoint, and then you got to find either the distance from the center to the point on the circle, or you could plug in your center and your point, one of the points on the circle, or you could find the distance between the endpoints. But if you find the distance between the endpoints, what do you have to do? What length is the endpoints of your diameter? What's that represent?
You have to find your midpoint.
No. To find the distance from the center, so the radius, what do you have to do to your diameter? Cut it in half. Okay? So if you're going to use the endpoints to find the distance, you have to make sure you divide by 2 before you plug it back in and square it. So in my opinion, of those 3 methods, that's probably the one I would recommend the least, just because that's the most people make mistakes on. Okay? So I would either plug back in the center and then one of the endpoints into your equation as the HK, the XY. Or I would find the distance from, I don't know if there's anything, from the center to the endpoint, and then that's and then make sure when you plug it in that you square it. Then came intercepts and symmetry, and then graphing the equation. Remember, this is all going to get looped into one question. So this is one of the ones that's worth 10 points. It's going to ask you for the intercepts, it's going to ask you for the symmetry, and then it's going to ask you to graph it. If you have enough information from the intercepts and the symmetry to graph it, feel free to go off of that. If not, then you're going to need to plot some additional points. Then came your piecewise function. So there's parts where you're graphing your piecewise function, and then there's parts where you're evaluating. So if something like B on this, you had to figure out that -1 would have been in the range on the top, then plug it into the top. On 7, you would have had to figure out that that's in the bottom. You would have plugged it into the one on the bottom. Okay, then came something like this. This is your graphing utility question. So this is actually going to get given to you first. You're going to get a yellow piece of paper that has the graphing portion on it. You're going to graph your function. You're going to plot the graph on the side so that I know if you got things wrong. Was it based on the graph that's wrong, or is it that you're reading it wrong? And then you're going to answer the following questions based on that graph. The domain, the range, the increasing, decreasing, the zeros, the max and min. Keep in mind, domain and range, increasing and decreasing, are going to be in interval notation. Max and min are in your coordinate point form. Zeros are listed, all the x values. Questions on that one? Okay, and then the last one is even or odd. Remember, it's even if it is symmetric to the y-axis. It's odd if it's symmetric to the origin. And then obviously it's neither if it's neither of those. You can do this based on your graph, or you can plug in your points because you're going to get given your equation. Just be careful not to take too long on this. When you are on this, I will eventually be if you are still on the graphing calculator portion, you need to move on. You can always go back to the graphing calculator portion, but once you're done with your test, you're done with your test. There's no sitting here after, okay? Because you guys all have at the end of the day, 2:30, you're done. You can't have more time than the other classes. So don't waste too much time on this. Don't waste too much time on any one question. If you get stuck, you need to move on and come back. Yep.
For the increasing, decreasing, if they share a point, it's parentheses.
Increasing and decreasing is always parentheses, except if your graph starts or stop constant, which to be honest, you won't get on a graphing calculator. If I gave you a graph, like a piecewise function, and maybe it started horizontal, that's the only time you're going to get a bracket. Or if it stops horizontal solid point, that's the only time you're going to get a bracket. Everything else is parentheses. Again, this one is worth, if there's 6, 7 questions, 2 to 5 points apiece. So this is a good chunk. Make sure you're carefully graphing that. Again, don't forget your calculator. There will be none shared, okay? Don't wait till tomorrow morning to learn how to use it. You should be bringing it with you. You should be knowing how to use it and comfortable so that you don't waste time on something like that. All right, then came the book stuff. So this started with 1-1. I did the odds, mostly odds, so that you could see the worked out answers on CalcChat. But then the ones that are evens are actually also on here, and some other ones that I've worked out in the past are also worked out on this document, which is posted on the assignment. This whole first page is odds. So this is your plotting points, obviously finding slope, finding the equation of a line, finding the equation of the line if it is perpendicular and parallel, like number 31. And then functions was 1, 2. So this now we're identifying if it's a function, determining if the equation is a function or the points. So remember the points is that no x can repeat with a different y. And then from the equation, y can't be an absolute value or raised to an even power. So something like 35 would fail that, and 41. Those would not be functions. Then we had evaluate the function where you're plugging the values inside the parentheses in for x. 43 is just a regular function. 45 is your piecewise function where you've got to figure out which one to plug it into. 47 through 50 was your domain. So again, you're looking for variable under the root, variable in the denominator, or the combination of the two. These are going to be given in interval notation. So 50 is there. It should have been 16 with a bracket on it to positive infinity. And 48 is negative infinity to positive infinity, because although there is a variable in the denominator, when it is x squared equals, or x squared plus 1 is not equal to 0, there is no value you can plug in there to get for it to be 0, okay? That no real number. That would be the square root of negative 1. So it's, oh, ignore this. This is if that was in the denominator, if it was x squared. 1, 3, domain and range of a function, either algebraically like we did before or based on a graph. So if this was graphed for you, could you find your domain and range? So these are some other examples like the one at the beginning. This just asks for domain and range, but it doesn't hurt to graph these on your graphing utility. Make sure you be able to answer the questions on domain and range, increasing, decreasing, zeros, all that stuff. Then came, yep. On the non-calculator part, like intercepts, you might get square roots, like we did for the quiz. Like if you got something that said like x squared equals 7, then your intercepts are plus and minus root 7. So when you give it to me as an answer, you're going to leave it as root 7, but when you go to graph that, you're going to approximate it. Okay. Yep, good question. Then we get to identifying a function from a graph. This is your vertical line test. If it fails, if you can pass the vertical line through, and it hits it more than once, it fails. So both of those, 63 would be a function, 65 would not. This is use the graphing utility to do the interval notation on the increasing and decreasing. 71 to 73, use the graphing utility to do the max and the min. So all of these are separated out. These questions and these questions and these questions, the domain at the top, they're all separated out on this review. They will all be put together just like the example that was on the second page. So it's all one section based on one graph. Your piecewise function, you are going to be graphing this by hand. You won't have a calculator after that point. On the bottom, on the left is your difference quotient. So again, make sure you know f of x plus h minus f of x over h, and you know how to do it. So the one that was even there is 54, and it should be 2x plus h minus 3. Yep.
For the test, you're not going to write that.
Nope. Yeah, you got to know it. It's not going to be in the directions. The directions will just say find the difference quotient. Okay, then came the very top of that, the even and odd. Again, that will be grouped together with your other graphing calculator question. And then we got into 1-4, which was transformations. So you're going to have a couple that are graph based on transformations. You will not have your calculator for that portion. It's also going to ask you to describe the transformations, give the domain and range, and the parent function. Just be really careful with those. A lot of work goes into those, like when you start to move things around and then people make the mistake of graphing the wrong shape because they get so carried away with the transformations. Okay, that would stink. Don't do that. And then finding the equation from the graph. So if I give you a graph, You need to know if it's reflected, shifted right or left, up or down. I will not do a non-grid stretch on the one that you have to give me the equation for. So it won't be something like 2 absolute value of x. I won't do that. Okay, but you can do reflection, horizontal shift, vertical shift. So just make sure you're ready for all that stuff. And then like 97 to 103, it kind of puts it all together. Identify the parent function, describe the sequence, sketch the graph, and then you won't have to do D on your test. You're not going to use the function notation to write it in terms of it, but what you will do is the domain and range.
Do you have an example where like you have to flip it across the line, but like it moves to the opposite direction?
Sure, like square root, or it doesn't matter, square root. Okay, so if it said f of x equals the square root of negative x plus 3 plus 2, let's say. So when the negative is underneath, for a square root, I know I'm going to point it left, but it also changes the direction on the horizontal shift. So this, instead of normally going left 3 units, this actually means I'm going to go to the right 3 units. So 1, 2, 3, up 2 units, and then my square root points left like that. If it was absolute value or a parabola, then flipping it left does nothing because a flipped V still stays the same. But what this does impact is, again, that horizontal shift. So instead of going to the left 3 units, you're going to go to the right 3 units. You're going to go up 2, and then you plot your V. So the only ones that actually change direction on the shape, this negative will always impact the horizontal shift. But the only ones that change direction on the actual shape are the square roots and the cubic functions. So if I had this, now it's going to the right 3, up 2, and then cubic function usually goes up to the right and down to the left. This is going up to the left, down to the right. This would be the same as if it's a parabola, because when you flip a parabola or a V, it still stays the same shape. It would just affect your horizontal shift. And then remember, the negative on the front flips it upside down. So if I'm describing those transformations, if the negative is underneath or inside the parentheses, then it's a horizontal shift, over the Y reflection. And then the other ones, if it's negative on the front, that's either over the X, or you can just say upside down. Okay, then came evaluating the combination of functions. This is your f of g of whatever, or f minus g, f plus g, f times g. Remember that the open dot is different than multiplication. This means take the 5, plug it into the g, and then take that answer and plug it into the h. Whereas this means find f of 1 and then times it by h, not g, h of 1. And then remember your domains. So if I had a value here, if this said f minus g of x, if it was an x and not a number, then if my domain has a restriction on the f, I carry it down. If it has a restriction on the g, I carry it down. If my new function has a new restriction, I have to add that in as well. Same for the plus, same for the multiply, same for the fraction. The difference with that and these composite functions is if it's f of g of 5, or sorry, it would be x. Then I have to look at the combination. So I would take g and I would plug it into h and see if there's a restriction on the new function. And then also account for the restriction on the one you are plugging into first. So if there was a restriction on the g, it gets carried down. And then if there's a restriction on the f of g, or h of g, I combine them. If there's a restriction on the h, however, I don't have to worry about it because that's the one that's getting plugged into. Questions on any of those? So let's say, like, for example, it says to find f of g of x. I'm going to take g of x, I'm going to plug it into f of x. So this would be 3 minus 2 square root x. Now, if it asks for the domain restriction from the beginning, I've got g of x that is square root of x, which means x has to be greater than or equal to 0. And then once I have my combined function, it's the same. X has to be greater than or equal to 0. So I'm not introducing a new one. My domain would be 0 to positive infinity. if f of x was 1 over x, and I found f of g of x, how does that change my domain? Does it change my domain? Yeah, how? My parent function still is that it's greater than or equal to 0, right? So that would still be part of my restriction, but then what happened? Good, it's greater than 0 because now it's in the bottom. Does everybody understand that? So now I've eliminated 0 as well. This one would be 0 to positive infinity. Questions? Yeah, Mary Angel.
For the one that's like the 3 minus 2.
This one? Yeah.
What if you accept that whole thing is 0?
No, the only thing that can't be negative is what's underneath the root. Everything else is fine, right? If I just said that this equals 0, I could solve that. That's not a problem. What's being restricted is what's underneath the square root. Same thing for a fraction. What's only being restricted is what's in the denominator. The rest of the function doesn't matter. So if I have a square root, I'm setting what's under the square root greater than or equal to 0. If I have a fraction, I'm setting only the denominator not equal to 0. Or if there's a square root in the fraction greater than 0. Yeah.
So for the test, if you were to put the second example that you did, would you,
This one? Yeah.
would you put the domain for the g of x and like the whole thing?
You'd have to look at both of them and say which one's more restricted. And because 0 to positive infinity is more restricted, that's your answer. Yeah. All right, and then remember you had questions of those based on graphs. Expect to see those too. Okay, those were in the notes and in the homework. Like if I said f minus g of 4 and I gave you 2 graphs, you would need to go to the f and find the 4, find the g, go to the g, find the 4, and then add or subtract whatever it says to do. So there's those based on graphs as well. And then after that was 1/6, so you can ignore the rest of that because we didn't get to that. That will be on your next test. Questions overall on the review? All right, all I can say is read carefully, please. If that says g of f of x, what are you plugging into what? F into g, so I'm taking this and plugging it in here. That would be 2 times 4x squared plus 2x plus 3 minus 6. Distribute in that 2. These cancel and I get 8x squared plus 4x, which is the red one. All right, I'll tell you this right now. Test-wise, you won't get the original parent function and the shifted. You're only going to get the shifted, so you would have only gotten that dashed one. This is an absolute value, so obviously your x has to be an absolute value, some part. And then it's shifted to the right 2, and it's upside down. So right 2 means minus 2 inside. Upside down means there's a negative on the front. So this is negative absolute value x minus 2.
What would negative look like?
So negative. Remember, good question, negative like this.
Uh-huh.
All right, listen carefully, folks. So the negative on the front is your upside down, right? This is upside down.
Hey, what was the game called?
I'll get you back in. Hang on. Guys. Negative on the front is upside down. The negative here flips your graph over the y, right? So if it's a V and you're flipping direction, it actually doesn't matter. But what it does do is change the direction of your horizontal shift. So this would now be a shift to the left 2, and then it would be upside down. If it was, let's say it's square root. Negative on the front is still upside down. Okay? This makes this go left 2 instead of right 2. And it changes the shape of your graph because with a square root, when I flip it from left to right, it actually changes the shape. So this would be left 2, upside down, and it would point left.
I'm so confused.
Yep. So if I take a V, right, and I flip it left to right, it's still a V, yes?
Yes.
If I take a parabola and I flip it left to right, it's still a parabola. If I take a square root function, flip it left, now it faces the other way. If I take a x cubed function, now it flips the other way. So these two, when the negative is underneath the square root, physically changes their shape. And if there's a horizontal shift, if it said plus or minus anything underneath, it also changes the direction of your horizontal shift. So that's true for all of that. That's true for a V, for an absolute value, for a quadratic, all of that stuff. If there's a negative underneath or inside the parentheses, it's going to change your horizontal shift. But with a square root and a cubic function, it also changes your shape. Does that make sense? Yeah? All right, if I plug 0 in for x, I get y squared. This would be gone. Plus 3y minus 10 equals 0. And then I get y plus 5y minus 2. Solve those and it's negative 5, positive 2. The x was 0. It's got to go in coordinate point form. I gave it to you multiple choice this time, but realize that for the test, you're going to have to write that out. Make sure you don't forget that it's xy. All right, so now we're talking x-intercepts, right? So the y is 0, so this would be 2x squared plus 10x equals 0. Take out the 2, x plus 5 equals 0. Set them each equal to 0. Divide by 2, it's still 0. Subtract the 5. And then it is negative 5, 0, because the y was 0, and 0, 0. All right, how do I find the center? Midpoint. So negative 3 plus 1 over 2, 6 plus negative 4 over 2. So again, this is multiple choice. Tomorrow's test won't be, but if this was a standardized test, you can already, guys, you can already rule out 2 of them just by that, right? Because I know it's got to be x plus 1 squared plus y minus 1 squared. Then you have options, but my advice is to stick to the standard form. So x minus h squared plus y minus k squared equals the radius squared. If I pick negative 3, 6, then it's negative 3 minus a negative 1 becomes plus 1. 6 minus 1 equals r squared. Negative 2, 5, and I get r squared equals 29, and you don't even have to do anything with that. You just plug it back in. If you do the endpoints of the diameter, then you've got to divide it by 2 and then square it. So be careful. It's extra work you don't need to be doing. So this, I told you before, but I'm going to tell you it again. I'm not giving you this. F of x plus h minus f of x over h. You have to know that. That's the first thing. You get that wrong, everything from here on out is obviously wrong. So I'm going to find f of x plus h by taking the x plus h and plugging it in everywhere there's an x. So negative 2x plus h squared minus 3x plus h plus 5. Now, we have done this so many times that you should already know what x plus h squared is. It will save you time. So it's negative 2 and x plus h squared is x squared plus 2xh plus h squared. If you don't know it, you just got to work it out. You got to FOIL it out. Then I'm going to distribute the 2. Negative 2x squared minus 4xh minus 2h squared minus 3x minus 3h plus 5. And at this point, nothing cancels. Then I have to subtract my original f of x, which is negative 2x squared minus 3x plus 5. That means the negative changes every sign that follows. Becomes positive 2x squared, positive 3x minus 5. The positive and negative 2x squareds cancel out. The positive and negative 3x's cancel out. And the positive and negative 5's cancel. So I get negative 4xh minus 2h squared minus 3h. What's the last step? Over h. Then I can cancel this one, this one, this one. Practice it, folks. It's the same steps over and over again. Practice, but be careful.